performing velocity analysis of a 4-bar mechanism. So in this case, you have velocity of job point NA is 0, 0, 0. Velocity of point NC is also 0, 0, 0. Omega of A, right? Angular velocity of A is a known quantity. Omega A is a known quantity which is in vectorial form 0, 0, theta A dot. And now omega B is 0, 0, theta B dot is an unknown quantity, and your omega C is also 0, 0, theta C dot, angular velocity of body C. This is our body C, this is our body B, this is our body A, and ground N. Okay, so these are unknown or dependent variables. So we will have to determine these to be able to determine the velocity of point BC. Okay, so let us write the equation for velocity of point BC. Velocity of BC is nothing but velocity of AB plus omega. Okay, first let us determine velocity of AB and then we'll talk about velocity of BC. Okay, velocity of AB is velocity of NA plus omega A cross position of AB minus position of NA. So this is a fully known quantity because omega A is known, velocity of NA is known, P positions are known from your position analysis. So this is fully known quantity, or you can determine this easily. Okay, next, velocity of BC. This is what we are interested in. Velocity of BC is velocity of AB plus omega B cross position of BC minus position of AB. So in here we do not know omega B. Now velocity of BC can also be written as velocity of NC plus omega C cross position of BC minus position of NC. So in this, your omega BC and omega B and omega C are unknown quantities. Now we need to determine the unknown quantities. Let us call this RB and let us call this as RC to simplify. Okay. Now let us equate these two equations first. Velocity of AB minus velocity of NC is equals to minus omega B cross RB plus omega C cross RC. Right. This is our equation. Now we have discussed earlier that when you are writing cross product of two vectors A cross B, this can be written as product of a matrix, a skew symmetric matrix, and a vector. Here 0 minus A3 A2 A3 0 minus A1, A2, sorry, minus A2, A1 and 0. Yeah, this is your skew symmetric matrix multiplied by B1, B2, B3. So your matrix multiplication can be written in this form. So we will use this in our equation. Let us call this as V, which is fully known. So vector V is equal to RV cross omega V minus RC cross omega C. I'm just changing this omega minus R to R, omega cross R to R cross omega. Okay. So now if you write this, let us see. Oh, okay, we need to go to the next page. Now if we write this, we have vector V equals to R B cross omega B minus R C cross omega C, in which omega B and omega C are unknown quantities. Now if we write it in skew symmetric matrix form, 0 RB3, so is it minus RB3? Yes, minus RB3 and RB2, and you have RB3, 0 minus RB1, and here minus RB2, RB1, 0, multiplied by your 0, 0, theta B dot, minus same thing, we can write this in skew symmetric form, skew symmetric matrix form. So here what you get ultimately is RB2 minus RB1, 0 times theta B dot. Same thing here, RC2 minus RC1, 0 and theta C dot. Here you have B1 and B2 and 0. Because this is a planar vector, z component is 0. You can ignore the third equation and write this in 2 by 2 matrix form. B1, B2 is equals to RB2 minus RC2 minus RB1 RC1, theta B dot and theta C dot. This is simply 2 by 2 inversion in your and these are your unknowns. Invert the 2 by 2 matrix, you will be able to find the dependent angular velocities. Once you know this, you can determine the velocity of BC. Okay.